Welcome to this video on the shape of data. By the end of this video, you should be able to determine the shape of a data set and understand what it means to the data it represents, and understand how the shape of the data has an effect where the location of the mean and the median are. All right, the first shape we're going to talk about is symmetrical. And when we say a data set is symmetrical, we're talking about from the mean, which is usually in the center. There are multiple ways to represent data, so I'll show you just a couple different kinds of ways to show. So this would be a curve. Okay, so your mean would be right here in the middle, and you can kind of see how they're the same going in both directions from the mean. So that's what we're talking about when we talk about symmetrical. Let me show you if we had a histogram, which is another way to display data. So I always envision it with this curve. If I throw a blanket over this distribution, you can see from the center it's symmetrical going both directions. So when we say the data is symmetrical, that's what we're talking about. Now, the number of peaks a data set has is really important. So when we look at this, it looks just like a mountain or a hill. It only has one peak. Okay? But there's different options that could happen. You could have a data set that has no peaks, and that's something that's called uniform. Okay, so uniform means it's pretty much the same across the top of the data. So if I gave you a histogram, and they might not be exactly the same, there could be a little variation here. But what you'd want to look at is if you threw a blanket over the top of it, it's pretty much flat going across the top. That's what uniform means, is the top, everything is pretty much the same. Okay? Then we have distributions that have one peak. Okay, so the peaks occur at the mode because the mode is the most occurring number. And so if you have one peak, we're going to call that unimodal. Okay, one peak. Uni means one. So let me show you in a dot plot. A dot plot is a way we can represent a group of, it's like a frequency chart. It tells you kind of how many fall into each category. All right, so if I look at this and I throw a blanket over it, I always like to do that. You can see this, there's only one peak. So that would be unimodal. In a histogram, you're only going to have one peak. Now I'm showing this one in particular because these two guys in the center are both the same height, but we're not going to say this has more than one peak, because if I throw a blanket over it, it still only shows the one peak. So that is unimodal. I'm going to skip to the bottom one and then come back to the next one. If a distribution has two peaks, we call that bimodal. Okay, so that's going to have two. So if I look at it, let me give you a dot plot here. Okay, so if I look at that, envision a blanket going over the top of it. It would go up and it would sag between and then it would come up again. That's bimodal. So this one still has two modes, but because they're side by side like that, they only make one peak. When they're separated, that's when we're going to call them bimodal. Okay, so that's pretty important to try to remember. So if we had a histogram, you know, they can be any, so you're going to have a peak and there's going to be some sort of gap between them, and then you'll have another peak. They might not even be the same size, but you're trying to envision the blanket. If it goes up and down twice, then that's going to be bimodal. Now, if we have more than two peaks, we call that multimodal. And we could get into all the prefixes, but once it goes beyond 2, we're just going to call it multimodal. So if I showed you in a dot plot, and we just kind of had some groupings that had some separation between them, and that's really what you're looking for, is you have things going on. But there's a separation. You have multi-modes, but they're all separated from each other. Okay? All right. So we've talked symmetrical. We've talked about peaks. There was a brief introduction to skewing with our box and whisker plot. So I just want to take it just a little bit further. So a skew occurs when the peak is not at the center of the distribution. So if the mode is not at the center of the distribution, you're going to have something that's called skewed. Okay, and so we had a couple shapes. This is one I'm going to use. I'm going to go up. Here's my mode. So that's where my peak is, and then it kind of tails off from there. Okay, so here's one way to kind of help you think about it. Draw a little tail on him. There's his eye. So we got ourselves a whale here. Okay, the mode is here at the peak, at his water spout. All right, but there's enough numbers out over here, you got to get like this long tail to come over and be part of them. So this would be skewed left because of where the tail is. We did this with our box and whisker plot, so this would be like in a box and whisker plot, the box would be up here where most of the data is. So that's what the box and whisker plot, and you could see his left whisker would be a lot longer. Okay, so let's try this for skewed right. Okay, I'm going to put the tail on the right. The mode is where the water spout is at the peak. Okay, but there's numbers out here pulling to the right, so that's skewing to the right. So in a box and whisker plot, most of the data will be right there under the peak. You'll have a whisker to that, and then you'll have this longer whisker going out to kind of relate it to what we talked to before. Okay, so skewed left and skewed right, it's where the tail is, where the little bit of data is versus most of the data. Okay, could be caused by outliers, it could be caused by different things, but that's what it's going to look like. So I actually do a couple skewed. I've got a skewed right here. You got your peak and then it tails off to the right, so that's a right skew. Okay, all right, let's flip this over. Let's talk about what happens to the mean median mode. We did a little bit with this already. So when you have a nice symmetrical distribution, I'm going to use this because it's a little cleaner than a dot plot. And so your mean, your median, and your mode all occur in the center. All right. So when we were talking about measures of center, if we said it was pretty symmetrical, we would use the mean versus the median. Really, they're pretty much in the same place. But once you start skewing, so if I skew left, all right, remember we said that peak is at the tall spot. That's the mode. That's the most occurring number still. But the mean is much more volatile. It gets pulled off a whole lot further than the median does. The median always stays in the middle. Okay? So that's one way to remember it, is the mode is the highest. The median's going to be in the middle, but the mean's going to get pulled the furthest away from what was the middle originally. If we hadn't had maybe some of these numbers, we would have been more symmetrical, but something happened way out to the side and pulled that arm to the left and pulled the mean way left, the median left just a little bit. Okay, so the same thing's going to happen over here on our skewed right. So we'll have a right skew. Our mode is the peak. That's the whole point of the mode. It's the most occurring number. The mean gets pulled much further, but the median's always in the middle because it doesn't get pulled as far as the mean does. Okay? All right, so that's just so you don't have to calculate it each time. You'll know the mean is going to be much smaller if you're skewed right. Or if it's skewed left, the mean will be smaller than the median. And that's why before we were talking about if it's skewed, you want to use the median because it's closer to the actual center of the data. So let's do just a quick little practice here of the shapes. I always like to envision a blanket going over them. So this is symmetrical. I would even say it's unimodal. Give a little more information. Okay. If I threw a blanket over this one, it's all flat on top. That guy is uniform. All right. Take a look at our next one. Throw your blanket over it. There's a gap between those two peaks. They're not the same height, but they're still two humps. So we're going to call that bimodal. Same here. Throw a blanket over it. It goes up and down. They're not all the same, but it's more than two, so we're going to go ahead and call that multimodal. I've got a couple of dot plots here. Throw a blanket over your dot plot. It is a unimodal. And it's symmetric. Okay. Okay, so we have one peak, so we can still call that unimodal. And the tail is to the left. You got most of the data here, but you got pulled off to the left, so we're going to call that a left skew. All right, we're going to do a little bit of practice with this later. I hope that was helpful. Let me know if you have questions. See you in class.